Now let's talk about understanding referential integrity in Power BI. Why is it important? And what are some of the best practices for data consistency? Now, what is referential integrity? Referential integrity ensures that the relationship that we have between tables in our Power BI model are valid, are consistent, right? Now, referential integrity also ensures that the primary key in one table must match a foreign key in another table. Now, referential integrity prevents orphaned records. So you can imagine if we have a foreign key that does not have a primary key, it means that that foreign key exists in a fact table, but we don't have the primary key in the dimension table. Now, with that, we are violating referential integrity. Let's go ahead. Let's talk about some of the basic key concepts and terminologies in referential integrity that are very important, that are very key to referential integrity. It is the primary keys and the foreign keys. Now, what is primary keys? Primary keys uniquely identifies each record in a table, right? While foreign keys establishes that link between the tables. So let me give you a very good example. So we have a customer table, for example. In that customer table, what you will find there is customer ID, customer first name, last name. You see a column for customer gender. Every descriptive information about different unique customers, right? So a primary key is that unique identifier, right? Now, the foreign key is what we use to establish the relationship between these tables, that is the fact table and the dimension table, right? So when the customer ID is in customer table, it is a primary key, but when it is referenced in the sales table, which is what we call the child table, so the dimension table, the customer table is parent table, while the sales table is a child table. So when the customer ID now appear on the sales table, it becomes a foreign key in that table because that is not its own original table, right? And the probability of it being unique in that table is not sure because you can have one customer that is going to, you know, make an order several times, right? Now, these two concepts, primary and foreign key, these two keys, they ensure that referential integrity occur in table relationship, and it also prevents orphaned records. Now, why is it important for a Power BI developer to understand referential integrity? Because as a Power BI developer, you are going to ensure that your data model and report is accurate. Also, as a Power BI developer, one of your core job or one of your core functionality is that you must prevent errors in calculations, in your visuals, and in your table relationship. As a Power BI developer, you must maintain data consistency and trust in your report. Your end users must be able to trust whatever report you are presenting or you are creating for them, right? Now, what are the benefits of referential integrity in a Power BI report? Now, referential integrity ensures that there's accurate relationship, right? Is you are ensuring correct joins between tables. Number two is consistent data, right? Referential integrity prevents mismatched or missing record. Now, when you enforce referential integrity in Power BI in your table relationship, right, it prevents you having mismatched or missing records because you can easily detect if there's a mismatch record or missing record at the early stage of you evaluating your data source or your data itself, right? Now, efficient queries. Now, when you enforce or you ensure referential integrity, right, it also helps you in performance optimization. It helps you in improving the performance of your Power BI report and also, you know, prevent you or you, it allows you, avoid that unnecessary data scans, right? Now, do you know that it is very possible for you to be violating refresher integrity in Power BI? Now let's go into ways you can be violating refresher integrity. Now, orphaned records. Imagine a foreign key that doesn't have a match, all right? Doesn't have a match in the primary key column of your dimension table. Imagine a customer with their IDs, right? In the sales table. You don't have a customer, we can see the ID of that customer, but that customer does not even exist in the customer table, right? So that kind of record is called an orphaned record because that customer exists in the sales table, which is the child table, but that customer does not exist in the table that has a unique list of all the customers. So it's a primary key, it's a foreign key on the sales table, but we cannot find a matching primary key on the dimension table. Those are the ways you can be violating referential integrity in Power BI table relationship, and you might not know, right? Now imagine your dimension table. Imagine one primary key appearing multiple times in multiple rows in your dimension table. That is another way you are violating referential integrity, right? It's not meant to be. You are not meant to have, because the primary key column is meant to have a unique list of all the customers. So anytime you are having one customer ID appear several times in your dimension table, then that is problem booming, right? It means that there is no consistency, right? You are violating referential integrity. Now, let's look at another example, missing keys. Do you know that sometimes if you don't check your data very well, if you don't explore your data well, if you don't validate your data well before importing into Power BI or before importing to Power BI desktop after you are done with your transformations in Power Query, you know that it's very possible that you have empty rows in your primary key values. You know that you might be having missing values. You might have other descriptive details, other attributes about a customer without the customer ID being there. So that is why it's very important for us to always check all of these things before importing our data to Power BI desktop, right? So make sure that there are no missing values in your primary keys. Your primary keys are not deleted, and you are also making sure that even if you are updating them, it will also be reflecting in your dimension table, right? Now, do you know that you can use DAX to detect if you are violating refresher integrity? That is very, very possible. So if you look at the calculation on my screen, you will see orphan sales equals to calculate count rows open bracket sales. What this count rows open bracket sales mean is that it's going to count the number of rows you have in the sales table. Now filter the sales table, right, based on the relationship that exists between the customer table and the sales table, right? So what this will do is that it will count the rows in the sales table and look for where there is no matching customer ID in the customer table, right? It will look for where there is no what matching customer ID in the customer table, right? Now, if you look at it, filter sales not related. The word related means it will count. If I was using just related alone, that means what will happen is that it will only count where there is a matching customer ID between the sales table and the customer table. But putting the not in front of the related will count where there is no matching customer ID between the sales table and the customer table, right? Now, there are different ways you can avoid violating referential integrity. Number one, make sure that you validate data sources, right? Ensure that you clean your data well. Ensure that your data is consistent before importing it to Power BI Desktop. Now, use accurate relationship, proper relationship between tables in your data model, right? Now, data cleaning. Ensure that you remove duplicates. Ensure that you know how to manage null values or mismatched keys, right? In case there are keys that are mismatching, ensure that you handle them properly based on your understanding of the data set and based on your understanding of the business process, right? Now, error handling, right? Make sure that uh, so many times or oftentimes that you are dealing with, you know, ensuring or enforcing operational integrity, you can use DAX to identify and resolve this operational integrity violation. Now, key takeaways here. Operational integrity ensures that data is what is reliable, relationships are valid, and your Power BI reports can be accurate and trustworthy. Gaining the trust of the stakeholder is very, very important as a Power BI developer. So you must always create reports that the stakeholders or your end users can trust. Now let's go into Power BI Desktop now, and I'm going to show you a typical example of how referential integrity works and how one can be violating referential integrity without knowing. If you look at my screen, you will see that I have customer table and I also have the sales table. I can call it transaction table. Now, on the customer table, you see that we have customer and customer ID and customer name. Now, the customer ID, you see customer ID 101, customer ID 102, 103, and 104, and all their names also, right? Now, on the sales table, you see the order dates, the customer ID, you see the quantity. Now, what you will observe here is that I have customer ID that does not exist in the customer table. See now, what customer ID 101, I have a corresponding or a matching primary key for it, which is the customer ID 101 in the customer table. Now, customer ID 102 also exists in the primary key, which is fine, right? Customer ID 103 also exists in the customer table, which is fine. Now, I have customer ID 105. Customer ID 105, there is no record or matching primary key for it in the customer table, but I have it in my sales table. Now, with this, I am already violating referential integrity, right? Which ensures that there should be consistency, right, in the relationship that exists between the customer table here and the sales table here. Now, let's dive into Power BI desktop. Now, this is my Power BI desktop. Now, that same data you are seeing there is what I also have on my in my Power BI desktop. So I have sales and I have customer. Now, let's do something now. Let's bring in a matrix table. Let's bring in a matrix table. Now, in this matrix table, what I'm going to do is that I have a list of all the unique customers, right? So I bring in the customer. Oh, let me just say, let me bring in the customer ID. It's fine. It's fine. It's good. Let me bring in the customer itself. It's good. Right? Oh, this is meant to be on rows also, right? Okay. Well, let me just use the table. Yeah, let me use the table chart then. Okay. Now I have this customer ID, customer name, right? Let me try and do like expand it so that you can see it very clearly. So I come to my row headers. Where is my values? Where is my values? Okay, values here, right? I increase to like 27. Good, nice. Nice. Okay. So what again do I want to increase? Let me increase the column headers also to like 25. Good. Perfect. It's becoming bigger and clearer. Now, let me now do like an implicit measure, right? I'm just going to drag in the quantity from the sales table inside here. Now, something happened if you notice. Now you will see that I have the sum of quantity for all of these customer IDs, all of these customers, but there is a mismatch somewhere. Now, there's a customer ID that does not exist in the customer table, but the customer has 22 in terms of sum of quantity, right? So this is not actually right? There's a mismatch. Now let's go back and see whether there's a mismatch. So I showed you in the Excel earlier that this customer ID 105 is that customer that has 22, right? In terms of quantity bots. Customer that has 22 in terms of quantity bot. This customer does not have any matching records in the customer table. That is why you see that the customer ID here is empty. So with this now, I have violated referential integrity. So the customer ID 105 is supposed to also, yes, there's supposed to be a record for customer ID 105 in my customer table, which has a unique list of all the customers that I have, right? Now, that is an example. Now, there is a way I showed you guys in the slide earlier on how you can know in case you have multiple mismatch, right, in your sales table, in your fact table. You have multiple mismatch. How can you detect the numbers of this possible mismatch that you have in your sales table, right? Okay, guys, so now I want to use DAX to actually detect if I am violating referential integrity here. So in case you have multiple records in your sales table, Maybe you have millions and millions of rows, and you want to detect if you are violating referential integrity, if there's a mismatch in terms of your primary and foreign key relationship between tables in your data model. So how are you going to do that is this. So just like I showed you earlier in the slide, you say calculate, you say count rows, right? Sales in the sales table, right? So it's counting all the rows in the sales table. And I'm going to use filter. It should filter the sales table, right? It should filter the sales table. And because there is a relationship between the customer table and the sales table, so I'm going to be using related. I'm using related because I'm on the many side of the relationship, which is the sales table, which is my fact table. Assuming I am on the one side of the relationship, which is my dimension table, which is the customer table, I'm going to be using related table, right? Now, related, right? Open brackets, then the customer ID column that I have in my customer table. Now, but I'm not going to just leave it like this. I'm going to put not in front of the related. So not, that is, I want to know the mismatching values, right? The count of those mismatching values, right? So null, sorry, not. Then I close the brackets again, again, and everything looks good now, right? Then let me bring in um a card visual, right? And dragging that's my formula there. So see that it's telling me that between customer table and the sales table, there is one customer ID that is not matching with the customer table. There's one customer ID in the sales table that is not matching with the customer table, right? That is not matching with the customer ID that exists in the customer table. So it means that there's no primary key for it, but there's the foreign key in the sales table. So this is a way we can check for if there is a violation of referential integrity in our data model. So guys, I'm going to do something now, right? I'm going to reopen that my Excel file where I have the data, my data source, and I'm going to create one more row here, right? And I'm going to give a customer ID that does not exist in the customer table, right? And I'm going to save this file and I'll close it. If I open it, it might not refresh, might not work. So I'm going to close that. I've saved it. Now I refresh again. You will see that this number is going to change to 2, right? And for every mismatch, it's summing up all their quantity in just one row on this table visual, right? So there is a customer ID for them in the sales table, but there's no corresponding matching customer ID for them in their parent table, which is the customer table, which is the dimension table, right? Now, I would like you guys to note something. Now, let me remove the quantity column, and you will see that before I brought in my implicit measure, I have a list of all the customer ID from the customer table, right? Now, look at this particular customer ID 104. Now, when I bring in the quantity, you will see that I am not seeing customer 104 again. And the reason for this is because customer 104 has not initiated any transaction with us at all, like on the sales table. So that's why it's not even appearing here at all. So with that now, I have not violated referential integrity. A customer might be registered on the customer table, maybe when they signed up on the e-commerce application or something. It's very possible that they have an account with the organization, and when they sign up on the app, all their details comes to the customer table, right, in the database. Now, a customer might be registered on the customer table, but might not transact with us yet. So that customer might not have, initiated any transaction or bought anything from the organization. But where we violate referential integrity is only when the customer does not have an ID on this customer table, but we are seeing the foreign key on the sales table, which is not meant to be, right? So guys, thank you for staying by, for watching my video. Please don't forget to subscribe, like, and share. Thank you. See you in my next video. Bye.